here? We got Jack and Jill, small bakery, of course. Fresh cookies, why not? They bake two kinds of cookies, plain and cookies with icing. Oh, fancy. The cookies are sold by the box, and Jack and Jill are confident they can sell all the cookies they make, but there are 3 constraints that limit their production today. One box of plain cookies requires 1.2 pounds of cookie dough. One box of ice cookies requires, okay, so a lot of constraints there. All right, so they're telling us that X is the number of plain and Y is the number of iced. So the requirement, one box requires 1.2 pounds of cookie dough. So yeah, but if you cut it to the chase, it's really kind of telling you flat out what we're looking for, because you got the plain, you got the iced, and then you got the total. So if I take 1.2, okay, no problem.
And for the test tomorrow, is it going to be like on the first quiz also?
Yeah, that stuff's fair game too. Yes, definitely a good idea to review that. So 1.2x plus 0.9y is going to be equal to 72. So they kind of guided you to it, because they're saying if we knew how many plain boxes of cookies we had, we would multiply that by the pounds that are required for each box. Right? Same idea for the ice. And that would give us a total of 72 pounds. All right. For the second scenario, it's saying that plain cookies get no icing, so I'm not concerned with that. The iced cookies need 0.4 pounds, so 0.4y.
How do you know if it's X or Y?
Oh, it says it. Yeah. They don't always give us that, but in this case they did. All right, so we have that information. All right. One box of plain cookies requires about 0.10 hours to prepare. All right, so now we're switching over to a time constraint, but it's still a relationship. It's 0.1 x.
Why wouldn't it be 0.4 equals 20?
Oh, it should be.
And also, wouldn't this be kind of like wouldn't this be like a bonus problem? Or could you give us a problem like this?
Yeah, this is a fair game. It's reasonable.
Test tomorrow?
Yeah.
Oh, makes sense.
Let me get my color scheme going in the right way. So this should be red. So 0.1x, 0.15y, and that would be equal to 9, total of 9. All right, so in each case, they kept the structure of it the same for us. We had no icing, then we had, no icing. 0.4 pounds of icing and a total amount of icing.
I mean, I guess they kind of set it up for us.
Yeah. And that's the only thing that makes it reasonable. Because if that wasn't given, then it would be definitely too hard. But
It's just like, you see how much information, and it's just like, it's like,
it's designed to scare you.
yeah.
All right. So now here's the thing. It's saying write 3 inequalities. I just wrote 3 equations, but we could easily make them inequalities, because what we're saying here is that these are constraints. Jack and Jill have 72 pounds of cookie dough. Nobody said that they had to use all of the cookie dough. So anything less than or equal to 72 would be fine. If I get to 72, that's okay. Right? They have 20 pounds of icing. Nobody said they needed to use all of the icing, so I can max out at 20, but I don't actually have to get there. And I think the last one's probably the most important one in terms of real life context. They have 9 hours to play with. Nobody said that they had to work for 9 straight hours, right? So maybe they're only working for 2 hours, but they have 9 hours. Like, their deadline is 9 hours away. If I tell you that you have a test in 12 hours, That doesn't mean you have to study for every moment of those 12 hours. It just means that the studying has to have finished prior to that 12 hours elapsing. All right.
Wouldn't it just be 4 laws equals 20? Because it's telling you they have 20 pounds by student? And equals 9 because it's telling you they have 9 hours prepared.
Say it again, sorry.
Why would you need to use the less than or equal to? Like, why wouldn't it just be equals?
Because that's the amount of time that you have available. That's what I was saying about the study. Like, just because you have 12 hours until the next test doesn't mean that you have to study for all 12 of the hours.
Less than or equal to.
Right, exactly. All right. So now it's just a matter of graphing these things. And generally when it's in this form, I want to do it by intercepts. All right. So off on the side here, you can make a little table if you want, but really you just need to know the X intercept and the Y intercept for each one. Right. So for the X intercept, remember we're covering up the Y part of it and then dividing. So I'll have 1.2x equals 72.
So that is 60.
Mm-hmm. So for the Y intercept, you cover up the X and divide. So 0.9 is getting divided into 72. All right, so it's really 72 divided by 9, which is 8, so 80. For the next one, the X-intercept is irrelevant because there is no X, so it's just a straight divide. All right, so if you divide 20 by 0.4, that's 50. Then for the last one, cover up the Y. Divide by 0.1, you're going to get 90. Divide by the 0.15, and I think it's 60.
And then you just graph those.
Graph them, and then you just got to get your shading right. All right, so for the first one, 60 and 80. Straight line. Now you could come up with reasonable labels for this. I'm going to call this equation 1, and equation 2, and equation 3, just to make the labeling a little bit easier. The second one is horizontal at 50. That's my equation 2. And the last one is going from an x-intercept of 90 to a y-intercept of 60. Nah, not really. Should go right through that intersection. I think I can work with that one. I guess it's not going through the intersection. All right, close enough. No, there's something, not mine though. All right, so then we just got to get our shading. All right, so what I want to do is I personally like the test point approach. 0, 0 is reasonable, but the good thing about using 0, 0 is you could test it very quickly mentally, because if I replace each of these values with 0, I'm going to get a 0, which is going to give me a true sentence.
How
So
do you know what points to use?
0, 0, unless it falls on, you could use anything you want. 0, 0 is the most convenient ordered pair in the history of mankind. If the line goes through 0, 0, choose something else. But make it convenient, all right? So you can't go wrong with that. So if I plug in a 0 for x and a 0 for y, this is going to 0 out. 0 is less than or equal to 72. So I'm going to shade below the black line. Plug in a 0 for y, true sentence. So I'm shading below the blue line. All right. Plug in a 0 here. That's telling me below the red. So that's telling me that I'm looking at this region,
And you can use that strategy for every single problem.
every single problem. All right. Now, sometimes they ask that little follow-up question that says, suppose the profit on each box of plain cookies is $3, and the profit on each box of iced cookies is $4. How many boxes of each kind of cookie should Jack and Jill make to maximize profit? Well, that's a different story because that requires you to think about the money aspect of it. But anything in this region is gonna lead to a profit because everything's gonna work out. But that's also telling you to create an additional equation, an additional inequality. So if I'm looking at 3 and 4, it would be 3x plus 4y is equal to p. All right, and so that really is extra because that's something called linear programming. We're not really worried about that just yet. It's a different topic for a different day, but that's how you'd set up at least the equation. And we'll talk about in the next unit how you can do more.